Okay, I will straight away go into example 3. Are we clear? Okay, let's go. Example 3. Page 152 if you do not know what I'm talking about. Now, the box just tell you that it's the other way around. From acceleration to velocity, you integrate. From velocity to displacement, you integrate. That's all. Okay? Now, let's look at example 3. A particle moving in a straight line passes through a fixed point O with a velocity of 20 meters per second. Okay, that means the thing will pass through O and it will pass in 20 meters per second. Do you understand this thing here? What they're talking about? Okay, Alright. Most of my markers are dead already, so let me take one whole new one out. Okay? Now, t seconds after passing through O, the acceleration A. That means the acceleration A is given by 6t minus 6t. Okay? Can understand what I'm talking about here? Okay? So t is measured after passing O. T will start. Understand? And the particle passed through O with 20 meters per second. Okay? Now, first question. Find an expression for the velocity of the particle in terms of t. Now, acceleration is this. So, velocity will be the integration of acceleration, right? I just want to know, are you okay with this particular concept? Yeah? Okay, Now, I'm going to integrate. Plus C, okay, and 6 over 2 is 3, Go on, go and write 6 over 2, 6 over 2 all the place. Okay, now, what's my objective now? To find what? C. Now, do you agree that when t is 0, v is 20? That means when it passes through O, v is 20. Am I right? Okay? So, I'm going to plug this in. 20 equals to c, right? I plug in 20 equals to c. So, therefore, velocity will be 3t squared minus 16t plus 20. Everybody clear? Everybody clear with the first part? Yes or no? Yes. Okay, good. Now, second part. Find the displacement of the particle when t is 2. Now, they want displacement. So, I'm going to find the displacement function first. Okay? Displacement will be integration of velocity, right? So, what will this keep in? 3t cubed over 3 minus 16t squared over 2 plus 20t plus d, right? How come I use d now? Because c used already, okay? Now, I'm going to simplify this. t cubed minus 8t plus 20t plus d. Do you agree when t is 0, s is 0? Because when t is 0, s starts now to move away. Do you get what I'm talking about? Okay? Look at the question again. Look at the question again. It says that a particle moving a straight line through a fixed point O with velocity t seconds after passing through O. Okay? So the displacement will start from O also. Do you understand what I'm saying? When t is 0, s is 0. So when I plug in, 0 will be equals to d, right? You cannot assume that the constant is 0. You must see. Because you see, for this part, the constant is not 0. Everybody clear? So, s will be what? t cubed minus 8t plus 20t. Because d is 0. Okay? Now, is this the answer to part 2? Find the displacement when the of the particle when t is 2. So, when t is 2, what's the answer? Do we get a 16? So this is a 16 meters. Are we clear? Can or cannot? Can, Now, next part, part 3. Part 3, yes. this is the part that I need to tell you something here. Okay. Describe the particle's motion when t is 2. Justify your answer. Okay? Okay. Now, because yesterday I told you, right, when a particle comes to instantaneous rest, that means rest, what is 0? V is 0, right? V is 0, right? Okay, so let's find out when it comes to instantaneous rest. When V is 0, I will have am I right? Correct? Okay. Now you tell me what is this? This is 3/1/3, right? Usually 10/03 you cannot tell what is it. So it's 3/1/3. It's easier, okay? Now let me sketch the diagram for you first. Okay? Now, initially at 0, all of you listen to me. T is also 0, right? And the velocity is 20, okay? According to the question. Okay? Now, at t equals to 2, okay, maybe I write lower down so that it's in line. T equals to 2, it's at instantaneous rest. V plus. That means the particle moves like that. Then come back, right? That is again at instantaneous rest when t is what? 3 1/3, right? Okay? At t equals to 2, V is 0, okay? V is 0, am I right? At t equals to 3 1/3. Okay, now I draw copy. This will be t equals to 3 1/3. I also have V equals to 0, am I right? It's also instantaneous rest, right? Okay, do you agree that the particle is at instantaneous rest when t is 2 and t equals to 3 1/3? Okay, so what does it mean? Okay, that means the particle comes to instantaneous rest when t is 2 seconds and when S is 16 meters. Correct? Do you agree when t is 2, S is 16? That means this one is when the distance here is 16. Correct? Everybody okay? Can or not? After which, what will happen? The particle turns and travel in the opposite direction until t equals to 3 1/3, right? Seconds. Do you understand here? Okay, you take this down because this is not in your textbook. I find that the textbook explanation is too big. If you read the textbook explanation, they didn't explain like that. They just tell you positive, negative, I think it's not right. You have to tell exactly like how it moves. Then it becomes clearer to you. Then you know how to describe later. Or draw the diagram later. Are we clear? Are we clear so far? Yes or no? Yes or no? But the textbook is actually a subset of what I'm saying. You know what I mean by subset, right? Okay, you look at the textbook explanation. When t is 0, t is 2 and 3 1/3. Can you see? They also solve. Then they say when between t0 and 2, v is positive. Okay, when t is 2, v is 0. Actually, it just means that it moves in this direction, then after that stop and then turn off. Can you see or not? Yes or no? Okay, now then they tell you what? For t between 2 and 3/1/3, v is negative. Of course, it's negative, but it's moving in the other direction. Can you see? Okay, then it will again stop at where? When t is 2, the particle comes to instantaneous rest and turns to the opposite direction. Now, it didn't say that it will stop again at 3/1/3. You understand what I'm talking about? That's why I say what they explain is actually a subset of what I'm saying. Everybody clear? I always try to be very precise now so that you know what's happening. Understand? Because if you go to higher level, this one is going to come in again. Everybody clear? Okay? Any questions for example 3? No, huh? Okay. Next, right? I'm going to read the question for example 4 first. Read the question. Read the question for example 4. Okay. A particle travels in a straight line so that t seconds after passing a fixed point O. That means now I also have a particle that moves past a fixed point O, right? Okay, I always draw out. Okay. Its velocity v is given by this. So the velocity is given by t squared minus 10t plus 9. Okay. So now my question is respect to O. Can I figure out all this already? Can I figure out all this already? Okay. Alright. Let's take a look. Find an expression in terms of t for the distance of the particle from O at time t. Now actually they are quite vague with the rules. It shouldn't be distance though. It should be what? Displacement. Do you understand here? Okay. So let's take a look at part 1. So this will be integration of this. Alright? Okay? What is my aim here? To find what? C. Okay? Do you agree if it starts from here, displacement will be 0 when t is 0? Everybody okay? Okay, so when t is 0, s is 0. Okay, I sub in 0, 0, so I will have c equals to 0, right? You see c, 0, 0, 0, 0, so it's 0. Can you see it? You cannot assume that it's 0 because just now I just showed that it might not be 0. Okay? So my displacement function will be t plus 9t, that's all, because the 0 is not there. Everybody okay with part 1? Can or cannot? Can, huh? Okay, now class, even if you do not know kinematics, how to do the difficult parts, this one at least can get, this will be 2 marks, so sure we get the 2 marks. You understand? Huh? The difficult ones cannot get, never mind. Understand? Whatever you can secure, you must secure. Clear? Okay, now part 2 now. The values of t when the particle is at instantaneous rest. This is the best thing on earth. Even if you cannot do this, you can do part 2 also, right? Okay? Instantaneous rest is when what is 0? V is 0. So I will have alright? T is equals to 9 or T equals to 1. Everybody okay? Okay, so actually, what do you think of already when I have it this way? This is T0, right? It will be instantaneous when T equals to 1. That means at T equals to 9, it will down, then T equals to 9, it will down again. You understand what I'm talking about here? Yes or no? Huh? Okay? Now, next. What did they say? Part 3. The distance travelled in the 3rd second. This is what I want to explain. Now, what do you mean by the 3rd second? That means between the 3rd second. That means in between t equals to 2 and t equals to 3. That is called the 3rd second. What if I say the distance travelled in the 4th second? 5 and 4, the distance between. 4 and 5 lah. No, my mistake. 3 and 4. My mistake. Aiyo, siao, it's like that sometimes. You understand what I'm talking about here? Okay, then let us revise again. What about the 5th second? 4th and 5th. You understand what I'm talking about? Can, Okay, my mistake, Okay, now, so, we will have, when t is 2, s will be, now, you plug in, you get a 2/3. I'm not going to show you this one. Just plug in the s formula. Everybody clear? Then, when t is 3, I will get s equals to, you just do -9. Okay? But look at what the question says. What do they want? Do they want the displacement or the distance? Look at the question. Do they want the displacement or the distance? The distance, right? I told you distance is different from displacement, right? Okay, now, all of you look, This is 0. This is t equals to 2. It will come to instantaneous rest. First, let me just draw a diagram. This is O. Do you agree -9 is over that side, the distance, and then 2/3 is over this side. I'm not in proportion here. I'm just sketching. Can you see? Okay, now, first of all, when t is 0, it will move right. Until where? Until further than this, right? Until when t is equals to 1. It will come to instantaneous rest, right? Then it will turn, correct? It will turn. Then what will happen? It will go, then maybe up to somewhere down here is t equals to 2. Because t equals to 2 is 2/3, that means up to here. Can you see what I'm talking about? Yes or no? Okay, then after that, it will go to where? When v equals to 0, it will go, what's the type? 9, right? That means it will go to, it will go on. This is when t equals to 3, right? It will go to -9. Everybody okay? But t is not 9 and 9 is further down. I don't care. You understand what I'm talking about? Okay, I repeat, this one might be a bit confusing to some people. Oh, look up now. I talk about displacement first so that you are clearer. When it's 0, it's at 0. When it is 2, it must be at 2/3. Correct? When it's at 2, can you see it's 2/3? Correct? But if you look at part 2, it is an instantaneous rest when t is 1. That means it must move right until t1 move, then it goes like that, right? If not, it cannot go to the other side. You get what I'm talking about here? Okay? Then when it's at t equals to 3, it will get -9. Agree? Now, what did the question say? What did the question say? They want to find the distance traveled in the 3rd second. Okay, how? 3rd second means from 2 to 3 lah. That means I only want this part, What do? I take 9 plus 2/3, right? Can you see? I'm not talking about displacement, I'm talking about distance. Okay, so the distance traveled will be 9 plus 2/3 and 9 2/3 meters. Are we clear? Okay, now then I want to ask a question. What's the displacement of the particle when t equals to 3? It's -9. Displacement is different, I told you, right? Displacement is where is the particle with respect to 0, with O. You understand? Everybody clear? So, can everybody understand why it's 9 2/3 now? Because I only want this straight red part. Everybody okay? Can or cannot? Can, Okay, now, next part. Part 4. The total distance traveled in the first 10 seconds after passing through O. You see, this is a very naughty question now, You understand what I'm talking about here? It's called naughty question. Okay, now why? Let me sketch this rubbish again, okay? Most study I can only finish until this part. Then no homework for the weekend. Go study for your WA. Are you clear? Are you clear, class? Okay, now all of you look, I'm going to sketch this diagram now. 0. I'm going with respect to time. All of you look up, please. Look up. This is t0. It will start to move, right? Then just now I say, this is when t is 1, right? Correct. Yes or no? Then t is 2 is somewhere here, right? Then it will move, right? Move all the way, right? Until which timing it will come to instantaneous rest again. 9, correct? That means it will move until t equals to 9. It will come to instantaneous, then it will turn again, right? Then I am supposed to find out when t equals to 10. There's somewhere there. I don't know where. Everybody okay? Can? Now what's the question? After I say all this, then what's the question? The total distance travelled in the first 10 seconds after passing through. Do you agree that I must find the distance like this, like this, like this? Correct? Now, when t equals to 1, distance is actually 4/1/3. Now, of course, you do your working. You plug into the S formula. Understand what I'm talking about? Then, what about when t equals to 9? The distance is negative 81. That means it's that side. Negative 81. Now, can you see? I know here, I know this is negative 81. But I need to know this part also, you know. Alright, how about when t is 10? The f is negative 76, 2/3, if you key in the formula. Understand? Now, what about the distance travelled that I must find? All of you look up. This is the important one. Okay, in the first 10 seconds. Now, all of you look here. From here to here is 4/1/3 meters. Can you see? I must take this times 2. Can you see what I'm talking about here? Just go there, come back again. So it's 4/1/3 times 2. First part, right? Right now. Now, you know this is negative 81. This is negative 76, 2/3. Correct? That means it's moving nearer to O already. Going back to O. Okay. I'm going to continue. All the time. What is this distance here? 81, right? Alright? So I must plus 81, right? Then I must plus what? Plus this tiny little bit here, right? Alright, now how would I get this length? I'll take 81 minus this one, right? I'll get the length here. Will be plus. So I must plus this distance here. Everybody clear? I repeat. I got to go from here to here and back. So it's 4/1/3 times 2. Everybody okay? Then I go all the way here is 81. Then I move back a tiny little bit here. So this is the distance. Correct? Yes or no? Okay, so when I add this all up, it's 94 meters. Now, the horrible thing is that sometimes they can ask for average speed. Speed is what? Distance divided by time. Total distance divided by total time. So what if I want the average speed for the first 10 seconds? It will be 94. Total distance traveled divided by total time, which is 10. So it's 9.4 meters per second. You must know how to do this. Everybody clear? And just now I made a mistake, right? I said third second is between 2 and 3. Fourth second is what? Between what? 3 and 4. Understand? Everybody okay? Alright, Okay, good. So that will be your example 4. Are we okay so far? Are we okay so far? Okay. Now I still got example 5 and example 6. But actually the homework that I'm going to give, right? Even if you read 2, 5 and 6, it's exactly the same kind of situation. Just that, okay, look at example 5, what do they give? They give the, what is that? EX only, E to the power. Okay, then you look at question 6. It's also very simple. It's just 2 particles colliding, that's all. Okay, now can I do these 2 examples on Monday? Okay, that's why I say no homework, right? Now I change my mind. No, I give up, don't know how to do, I do for you, no? All the answers are uploaded. Why you worry? Even if I don't give, it still exists, right? You have to do next week. Understand, no? Okay. Don't worry, don't worry. This one I will not collect until you have finished. Okay? What's the number on the content page of KMS now? 22. 22. Today is also 22. Wow, very good. Is it 22 today? Yes. Oh, 22 summer. Wow. Very lucky. So must buy 2222. Okay. Exercise 18.2. Kinematics. Now, okay, I will say this. 18.2 will not be due until next Wednesday. Fair enough? Fair enough? Because I still got 2 examples to go to, and I still need to see whether you know how to do the homework. Okay? So, foolscap is a very kind act, from this act of kindness, okay? 3, 5, 6, 7. And, wow, still got 1. So sorry. Got 4. 9. Stop the video.